welcome to today's lesson, which is on variable acceleration. Now this is for mechanics, mechanics 1, for A-level maths. So let's just get on with it. So if you've been following some of the videos, or if you've been following some lessons so far, then you may have already come across, this is what you should have already done, and you should have already come across acceleration, which is being constant throughout. So these look like straight lines. So we've got a straight line going up there with that constant acceleration. We've got no acceleration there at top. We've got constant acceleration going down. And these are the kind of things that we've already seen. So what we're going to be looking at now is how the acceleration is changing over time. And here we've got a curve. This is for the velocity is equal to a half t cubed. And you can see this is a curve going up, and that means the acceleration is changing over time as well. So let's have a little look at one question then. So the first question here says, the velocity time graph of a body is shown above, which is the one you can see just here. What is the velocity after 4 seconds? So this is example 1. Make sure you're getting this down in your notes. It's not enough just to write this down. Make sure you are always copying the example. The only way to learn maths is to do it. So the first one here, we've got velocity is equal to a half t cubed. That's shown on the graph. So the first part here, for example 1, says, what is the velocity after 4 seconds? So, I mean, this is quite straightforward. We've got the time, we've got the velocity, so we sub that straight in. V is equal to a half times by 4 cubed. We'll do that on the calculator. So 0.5 times by 4 cubed is equal to 32, and that's going to be meters per second, like so, because it's velocity we're talking about. Brilliant. So part B says, how many seconds have elapsed when the velocity of the body is equal to 108 meters per second? So this is just working the other way around. So instead of subbing in the time, we're going to sub in the velocity. So here we've got 108 is equal to a half t cubed. So we're going to get rid of that half by timesing by 2. So 108 times by 2 is equal to 216 is equal to t cubed. And to get rid of that cubed, we're going to cube root all of this. 216 is equal to t. So the shift cube root of 216. So t is equal to 6 seconds. And that's that question done. Brilliant. So let's have a look at another question. You might want to pause and have a go at this yourself. This one isn't too difficult. I'll make it big for you so you can have a go at it yourself. So pause now and have a little go at that one. Okay, so I'll run through it quickly. It shouldn't take too long to do this one. So, here, a body moves in a straight line such that its velocity is equal to. So this is example 2. So velocity is equal to 2t squared minus 16t plus 24. So first of all, find A, the initial velocity. Well, the word initial means that our time is equal to 0. So what is the velocity when it started? So when t is equal to 0, this is what I'm going to be subbing in. So it's going to be 2 times by 0 squared minus 16 times by 0 plus the 24. Well, anything times by 0 is going to be 0. So I just end up with v is equal to 24 meters per second squared. And there I've got my velocity. Brilliant. So that's the first part. Calculate the values of t when the body is instantaneously at rest. So part B is saying when the velocity is equal to 0. So what is the time when the velocity is equal to 0? So this time round I'm going to set the velocity equal to 0. So I'm going to say that 0 is equal to 2t squared minus 16t plus 24. So let's have a little look at that. We can sub that straight into our calculator. So a polynomial degree 2. So it's going to be 2t squared minus 16 plus the 24. So we get two solutions. We get when t is equal to 6 seconds. And we also get when t is equal to 2. So these are the two times when it is at rest. So part C. What is the greatest value of t when the velocity is equal to 64? So this is very similar to what we've been doing, but it's asking for the value of t when the velocity is 64. So this is very similar to what we've just done. However, it's not the velocity isn't 0 at this stage. The velocity is equal to 64. So I've got, in this case, 64 is equal to 2t squared minus 16t plus 24. So again, I need to make this equal to 0 first. So let's take that over. 0 is equal to 2t squared minus 16t. 24 minus 64. 24, oops. Minus, I'll do that in my head actually. 24 minus 64 is equal to minus 40. And then we need to sub it in. So our first one is equal to 2. Next one is minus 16. Next one is minus 40. 1 minus 40. So we get two solutions here. T is equal to 10 seconds. And t is equal to, wow. The reason it says value on this one is because the second t is equal to minus 2 seconds. And we can't go backwards in time. So we just get one t here, which is the 10 seconds. So the next one, find the greatest speed of the body in the interval of between 0 and 5. Now with this one here, because we're trying to find the greatest speed of the body, we're looking at the time when this is peaking, okay? So we're looking for the maximum. So we're looking here, the greatest speed of the body in the interval between 0 and minus 5. So this one here isn't quite as easy as it looks. But what we need to do is we need to figure out what this graph looks like, and then we can think about what the maximum value of the speed is. So luckily we've got our calculator so that we can do this. So let's do this one. I'm going to move this one up here. So let's do D up here. Now we want it between 0 and 5. So let's have a look at, first of all, let's find out what the minimum is. We've already actually worked out what the initial velocity is. The initial velocity here is 24. So when I draw this graph, we know that it's going to be equal to 24 meters per second, there, like that. But we need to know what this graph's going to look like. Well, we know it's a quadratic. We know that it's a positive quadratic, so it's going to be a U shape like this. So when I draw this, I want to sketch this in. So it's going to be putting back 2 minus 16, and it's actually this one here, which is positive 24. So we get a crossing value at 6 and 2. So I know that it's crossing here at 2. It's also crossing at 6, but we're going to think about 6 is over here. But we only want it between that and 5. We know that tells us what the minimum value is on this. So a minimum value is 4 minus 8, which is over here somewhere. So it's going to be 4 across, minus 8 down, like so. So this graph is going to look like this. So we know at 0 it's 24, at 2 it's equal to 0, at 4 it's equal to minus 8, and at 6 it's equal to 0 again. Now this says it wants the greatest possible speed of the body in the interval between 0 and 5. So at 5, we know it's still negative because it hasn't come back up yet. So the greatest speed at this point here for D is equal to the starting point when it's 24 meters per second there, like so. So that's the greatest possible speed, and we know that because it comes down, it does start coming back up. If we went past 6, it would probably have a greatest possible speed past 6 over here. However, it only wants it between 0 and 5, so that means that we have a greatest possible speed between these values, which is the 24. So let's just check all these answers here. Brilliant. Perfect. So let's have a go at, let's move on to our next part of this lesson. So we've just discussed the fact that we can represent our velocities in terms of time. And when we have this, then our acceleration is changing. So we get this curve which is changing. But actually, if we know what the velocity is, we also know that acceleration is the change in time of velocity. And we also know that displacement, to find the velocity, is the change in displacement over time. So let's have a little look at this, because this is going to be the kind of the big part of this lesson. We know how to sub values in, but looking at this one here, I'm going to make this big so you can see it. So I'll read it out to you. In this chapter, we saw that the velocity v is the rate of change of displacement, i.e. the gradient. So it's the gradient in this curve that we've been looking at. Now in pure, we know that we can use differentiation to find the gradient. So if I differentiate the velocity, if I have the velocity, I know that's equal to the change in displacement over time, ds by dt. And obviously the same way here, I also know that the acceleration is the change in velocity over time, or the second differential of the displacement. So d2s by dt squared. So if I know what the displacement is, then I can work out what the velocity is and also what the acceleration is. So let's have a look at this question. So maybe get this one down in your book. A particle P is moving on the x-axis at a time t seconds. The displacement x from a point 0 given as x is equal to t to the power 4 minus 32t plus 14. Find the velocity when t is equal to 3, the value of t when p is instantaneously at rest, and the acceleration of p when t is equal to minus 5. So let's cut back. So the whole point here is they've given us now the displacement. This one here is example 3. Make sure you're getting this down in your notes. Remember, the only way to learn maths is to do it. So here I've got x is equal to t to the power of 4 minus 32t plus 14. They've given us the displacement. This is what x is, the displacement. So the first thing we can do if we know the displacement in terms of t, is we need to work out what the velocity is, but also what the acceleration is. Now to work out the velocity, I know that the velocity is equal to dx by dt. So I'm differentiating this with respect to t, and that's going to be equal to 4t to the power of 3 minus 32. So my velocity, the change in displacement over time, is equal to 4t cubed minus 32. So if I then want the acceleration, this is going to be equal to the change in velocity over time, which is equal to d2x by dt squared, which is equal to, I'm going to differentiate this one which is above it. So this is going to be equal to 12t, like so. And then I can use these formulas to work out the things that I want to find. So part A says, find the velocity of p when t is equal to 3. So I'm going to be using this velocity formula here. So the velocity is equal to 4t cubed minus 32, and I want it when t is equal to 3. So let's sub those values in. So it's going to be v is equal to 4 times by 3 to the power of 3 minus 32. Nice and straightforward. So 4 times by 3 to the power of 3 minus 32, which is equal to, the velocity at that stage is 76 meters per second. Find the value of t when p is instantaneously at rest. So it's saying now, what is the value of time when the velocity is 0? So I'm going to set this equal to 0. 0 is equal to 4t cubed minus 32. So v is equal to 0 meters per second. There, we're just letting the examiner know that we know what we're doing. So with this one here, let's take that 32 over. So 32 is equal to 4t cubed. Divide by 4. So 32 divided by 4 is equal to 8 is equal to t cubed. And then I want t on its own. So the cube root of 8, I mean, I could do that in my head. I should have done it in my head, really. So shift the cube root of 8 is equal to t is equal to 2 seconds. Okay, on to question C. Now you might have noticed that when I was differentiating this, that I forgot to put the squared on there. Obviously this is 3 times by 4, which is t, and 3 take away 2, which is to the squared. So I've just added that on there now. So part C says, find the acceleration when p is equal to 1.5. Now at the start of this, we found out what that acceleration was. So we know that for part C, acceleration is equal to 12t squared. That's what we worked out at the start. So here we've got our acceleration is equal to 12 times by 1.5 squared. So let's work that out. 12 times by 1.5 squared, which is equal to 27 meters per second squared, like so. So let's just check these answers. So we've got the first one, which was 76, which we got. We got the next one, which is 2, brilliant. And the last one, which was the 27, which is what we've got there. Brilliant. So let's have a go at another one of these questions. Now I'll put this up so you can pause and have a go at this one yourself. Have a little go at this one yourself. Okay, let's read it out. So putting the cat's displacement from the house is t cubed minus 3 over 2t squared minus 36t, where t is in seconds. Determine the velocity of the cat when t is equal to 2, the time at which the cat will be instantaneously at rest, and what's the cat's acceleration after 5 seconds. So this is nearly a carbon copy of the one we've just done, so it shouldn't be too tricky. So this was example, what was it? We're on example 4, I think. I'll just do this one really quickly. So you should have had a go at this one yourself. So we start off with the displacement equal to t cubed minus 3 over 2t squared minus 36t. First thing I'll do is I'll work out the velocity, which I know is dx by dt, which is equal to 3t squared minus times by 2 is going to be minus 3t minus 36. I'll also work out the acceleration straight away, which is going to be the change in velocity over time, which is equal to d2x by dt squared. So let's differentiate this one, which is going to be 6t minus 3. Brilliant. So now I've got the displacement, the velocity, the acceleration. So the next thing I'm going to need to do is to think about this question. So part A says, determine the velocity of the cat when t is equal to 2. So the velocity is this one here. We want it when t is equal to 2. So v is equal to 3t squared minus 3t minus 36. So v is equal to 3 times by 2 squared minus 3 times by 2 minus 36. So 3 times by 2 squared minus 3 times 2 minus 36. The velocity there is equal to minus 30. Brilliant. So let's have a look at B. So with B, it says determine what time the cat will be instantaneously at rest. So I need to make this equal to 0. So it's at rest when V is equal to 0. So I'm going to say that 0 is equal to 3t squared minus 3t minus 36. Let's put that into our calculator. Polynomial, degree order 2. So 3 minus 3 minus 36. So we get t is equal to 4 seconds. And t is equal to minus 3 seconds. So we're just dealing with this one here. Super. So let's have a go now at part C. So part C says, what is the cat's acceleration after 5 seconds? So this is part C. We've already got our acceleration up here. So my acceleration, which is the dv by dt, which is d2x by dt, which is equal to 6t minus 3. So I want the acceleration when time is equal to 5. So 6 times by 5 minus 3. So 6 times by 5 minus 3 is equal to 27 meters per second squared because it's acceleration. Brilliant. Let's just check those answers. So we got minus 30, t is equal to 4, and 27 for that acceleration. Super. So, I am going to carry on with this. We're just going to move on to the last little part of today's lesson, which is maxima and minimum problems. So, we know that from pure, a maximum and minimum point is when the gradient is equal to 0. We've got that flat curve like that. So, therefore, we know that we get a maximum velocity when dv by dt is equal to 0. Okay, so when that acceleration is equal to 0, we know we're getting a maximum velocity. Okay, let's get this question up because I want you to get this down in your notes. So, a child is playing with a yo-yo. The yo-yo leaves the child's hand at t is equal to 0 and travels vertically in a straight line before returning to the child's hand. The distance s meters of the yo-yo from the child's hand, the distance s meters of the yo-yo from the child's hand after t seconds is given by s is equal to 0.6t plus 0.4t squared minus 0.2t cubed. Justify the restrictions of 0 and, between 0 is less than or equal to t is less than or equal to 3, and find the maximum distance of the yo-yo from the child's hand, correct to 3 significant figures. So, the first part of this is saying to justify these restrictions. Now, the only way you can really do that is by thinking about the graph. What does this graph look like? Does it make sense? So, first of all, let's start off. We know that we're talking about displacement, velocity, and acceleration, all in terms of time. So, let's first of all work out what each of those are. So, I know that my displacement is this. That's what I know my displacement is. So my velocity is going to be my change in s over time, the change in displacement over time, which is equal to 0.6 plus, differentiate this, times by 2, take away 1, 0.8t minus, times by 3, 0.6t squared. Super. So, next up, let's work out our acceleration, which we know is the change in velocity over time. We could say d2s by dt squared, which is equal to, differentiate that, which we get is going to be 0. Differentiate this, we get 0.8 minus 1.2 t, like so. Super. So we've now got our displacement, we've got our velocity, we've got our acceleration. We've got all of these things. So it says justify the restrictions between 0 and 3. Let's think about what our displacement is going to look like of this yo-yo. So let's use our calculator to sketch the graph. So we'll get the polynomial up. Degree order 3 this time. I will need to put it in the order of this one here. Don't have anything over here, so it's going to be minus 0.2 for the cubed. Just making sure I'm taking my time to get this right. 0.4 for t squared, yes. 0.6 for t, and then there's nothing at the end. So we're going to get graph here between 0 and 3. This is a negative cubic, so we know that it's going to be looking like this. We get 3 intersection points, one at 3, one at -1, which is over here, and we get another one at 0, which makes sense. That's nice. So we get we know that it's going to be a negative cubic, so we know that it's going to be starting up here actually and coming, no, they're starting this way and coming down and then looking like this. So it's going to come down like this, it's going to go up, and it's going to go down like this. So our displacement is going to go up like this and come down like this. Now, if I look at these restrictions, because I know that the yo-yo leaves the child's hand at t equals 0, if I think about this, and I've got I'm going to try and draw this, not going to be very well. If I've got a hand like so, and he's got a yo-yo in his hand, there's the yo-yo, like so. So, at t is equal to 0, this yo-yo is leaving his hand. What this is telling me is it's coming down like this as well. So if I follow my hand like this is coming down like this, so it's getting further away from the hand. At this point here, this is the maximum away from the hand it's going to be. So this is when the yo-yo is at the bottom. So this here is when the yo-yo is at the bottom. And then what's happening is, as this gets closer to his hand, it's going to come back to here, and it actually comes back to his hand at 3. That's what this is telling me here. It's telling me he's coming back to his hand at 3. If it was to continue past 3 seconds, this means that it's going past his hand the other way. So it's going kind of down, up, but then the yo-yo's going past his hand, and this can't happen, okay? So if we want to justify the restrictions, what we'll say is the yo-yo leaves his hand at time equal to 0, and it gets back to his hand at t equals 3 with a maximum distance away from his hand in between this. If it was greater than 3, then we know it's going past his hand. Okay, and this is what they're looking for, and this is the explanation that we're going to write. So the yo-yo starts in his hand at t equals 0 and goes back to his hand at t equals 3. If time was greater than 3, the yo-yo would be moving up past his hand and this can't happen. Brilliant. Let's just make sure you can read that. This can't happen. So here, it's quite hard to understand that, but this is going to be the graph, exactly the same as what we've just done. So here we've got here the time coming up here. Time can't be negative. However, if we're going past here, we can see that it's going past his hand. Brilliant. So I think our explanation is actually a little bit better than that. I won't mention it to Dr. Frost. So let's have a look at part B now. Find the maximum distance of the yo-yo from the child's hands. Well, this is the thing that we're looking at here. We're trying to find this maximum distance here. And we're finding this when the velocity is equal to 0. So when the velocity is equal to 0, we know, so this here is going to be the maximum point. So it's worth stating that straight away. I don't think we actually needed to work out the acceleration in this, but that's okay. So for part B, we have a maximum displacement when the velocity is equal to 0. We can say here this is also equal to ds by dt being equal to 0, so the change in s over the change in t. And this is the thing that we're looking at here, this one. Okay, when this is equal to 0, we're going to get a maximum here. And this makes perfect sense, because if I'm throwing my yo-yo down, it's coming down here, it's got velocity. When it hits the bottom, my velocity is 0, it's stopping, and then it's moving back up. And that's what's happening here. So it's coming down, 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 it hits the bottom, my velocity is equal to 0, my gradient there is equal to 0, and it's coming back up. So we're going to make this one here equal to 0. So velocity is equal to, I'm going to put it in the right order just to make it easy for when I'm putting the calculator. So minus 0.6t squared plus 0.8t plus 0.6. I want that to be equal to 0. So minus 0.6t squared plus 0.8t plus 0.6. So with this one, I want a quadratic this time. Polynomial 2. Minus 0.6. Positive 0.8. And 0.6 there. Sub that in. We're going to get a time which is equal to 1.87 seconds. 1.87 seconds. And we also get this or minus 0.535. We can't have that because we can't have a negative time. So that is the time. So we've got the time that this occurs. The question's asking for what's the maximum distance of the yo-yo away from the hand. So if we know this is the time, but we want the maximum distance, we want the distance when this time occurs. So I go back to my original equations. I know that I want the displacement here. So S is equal to 0.6t plus 0.4t squared minus 0.2t cubed. This is the formula for the displacement in terms of time, and I want the displacement when I've got this time. So I'm going to be subbing in these values here. So it's going to be, let's write it down actually, 0.6 times by 1.87 plus 0.4 times by 1.87 squared minus 0.2 times by 1.87 cubed, like so. So with this one, let's sub all that in. 0.6 times by 1.87 plus 0.4 times by 1.87 squared minus 0.2 times by 1.87 all to the power of 3. So that's equal to, displacement is equal to 1.21 meters, like so. So there's the maximum distance away from the hand, and that occurs at time 1.87. So let's just check that that's right. Brilliant. Super. So we've got 2 questions here for you to have a little go at. So pause now and have a go at those yourself. I'm going to put that there so you can see it. So pause now and have a little go at those. Okay, I'm just going to put the answers up for these because I think you should be able to do these yourself. So for this one here, we have the maximum velocity when the acceleration is equal to 0. So dv by dt is equal to 0. So we differentiate that first. We set it equal to 0 and solve to get t is equal to 8. We do get t is equal to minus 2 as well. However, that's not going to work. And what is the maximum velocity? Well, now we've got to sub that back into the velocity, which is this one here. So we sub that back in, and we're going to get it at 52. For this one here, very similar. Find the times when P is instantaneously at rest. So we know that P is going to be at rest when the change in velocity and the change over the change of time is equal to 0. So when the acceleration is equal to 0. So we're going to differentiate this one and set it equal to 0. Very similar to the one above. We actually get 2 times here. T is equal to 2 and T is equal to 5. And here it says, find the greatest speed of P in the interval between 0 and 4. Now to do this, it's worth sketching the graph. Okay, let's have a little look at this. So they have subbed in 0 and got velocity is equal to 20. That makes sense. They've also worked out the acceleration when it's 0. I would also work out what this is at 4 just to make sure that you can check. If we sketch the graph, they're not going to sketch the graph because it's in the mark scheme. But here we've got a maximum speed of 20. 5 marks, that's worth there. So quite a few marks. Brilliant. So, thank you for watching this video on variable acceleration. Make sure you're having a go at these questions. This is only part 1. There is a part 2 which I'm going to be recording as well at some point. But make sure you're having a go at these questions because the only way to learn maths is to do it, and have a wonderful day.